A complex number is represented by a point in the complex plane. The complex number has the rectangular coordinates 2 root 3. Which of the following is one way to express the complex number using its polar coordinates? Well, this is how complex numbers work. You treat it like a regular old point, all right? And this would be like the real axis, and this would be the imaginary axis. So if I were to pretend that this is a point in the regular rectangular plane, you would go right 2, and then you would go up, let me see, root 3 is like 1.7, so 2 times 1.7 is like 3.5-ish. So you would go up 3.5-ish, and you would end up somewhere up here somewhere. Little context for you. So now, though, I need to turn it into polar coordinates. Well, what polar coordinates do is it gives you an r, which basically stands for radius, but really what it means is the distance from 0 to the dot, and then theta, which is the angle created from the positive x-axis to the side that you are creating right here. So I need to find r. Well, that kind of seems like, well, if I know that this is like, 2 over and 3.4 up, why don't I just do the Pythagorean theorem? And to find theta, which would be this guy, why don't I kind of just do SOHCAHTOA type stuff, and I know what the adjacent is and I know what the opposite is, so let's use TOA. Well, I have news for you kids. That's exactly what we're going to do. I just wanted to give a little context beforehand. Now, we do what we're about to do because it looks like Pythagorean theorem. If I give you rectangular coordinates and you need to find r, you find r by taking the square root of whatever this is squared plus whatever that is. So we'll call you a, we'll call you b, so a squared plus b squared. Again, if you're thinking, wait a minute, the square root of a squared plus b squared, that's like the Pythagorean theorem, only that's r and not c. That's exactly what it is. You're absolutely right. If you're thinking that, good work. Good on you. But what's my a? We called a 2, so 2 squared. B is 2 root 3, so we'll 2 root 3 square. Okay, 2 squared is 4. 2 times 2 is 4. Okay, root 3 times root 3 is 3. So 4 times 3 is 12. Don't know why I put parentheses around that. But what we get is we get square root of 16, which is 4, baby. So what we have so far is we have an r of 4. What we don't have is theta. Now, again, what I showed you before, what we saw before is we basically put a dot right there. We knew that this was 2. We knew that this was 2 root 3. And my job is to find this angle right here. Well, if I was thinking SOHCAHTOA, I would think that the tangent of theta is going to equal the opposite over the adjacent. Or we could just write out that theta equals the inverse tangent of b over a. So have that guy memorized. Have you memorized? Have you memorized? That's going to equal the inverse tangent of what was b, 2 root 3 over 2, which simplifies to the inverse tangent of cross you out root 3, which is pi over 3. Took a second there. All right. So now what we do in order to write this out in complex form is written out as r cos theta plus I r sine theta. So we know r is 4. So r is 4 cos. We know theta is pi over 3. So pi over 3. Plus 4i, I did a little switcheroo there, sine pi over 3. So it looks like you. Tricky. Tricky, tricky, tricky. If you looked at this, though, you might be able to notice that you kind of remind me of a 30, 60, 90 right triangle. Well, because it is. And if you notice that, that might make life a little bit easier. But, it's a little fun stuff. Hope this helps.